So good morning, dear students. So in order to understand the universe, we must know the language in which it is written, and that language is physics and mathematics. A very good morning to all of you present here. I, Mr. Pascal Fernandez, Dean of Science Department, extend a warm welcome to each one of you. We have our resource person, Dr. Divyamani BG, to enlighten all of us more about the topic where mathematics meets physics. I take pleasure in welcoming you, ma'am. I also welcome the principal, Mr. Sunny Gudino, vice principals, Mrs. Pushpalata Aras, and Miss Princy Flavia Pinto, and all my staffs and all my dear students. A very warm welcome to one of you. Now, I would like to I would like to request Mrs. Kavita, the coordinator of webinar, to lead us into the prayer.
Let us all close your eyes and pray. O Lord, we thank you for this day and for this time which you have given us. We have gathered here to gain knowledge through this webinar, which is on the topic where mathematics meets physics. We pray that you would enable us to make the best of it. I ask this prayer through your son. Amen.
So thank you, ma'am. It is no less than an honor to have among us Dr. Divyamani PG, Assistant Professor, Tunga Mahavidyalaya, Tirthahalli, Shimoga District. So Dr. Divyamani completed her MSc in Physics from Kuvempu University in the year 2006, followed by MPhil in Quantum Information Theory in 2008 from the same university. Qualified SLET in 2014 from Mysore University and PhD in 2016. She also attended international workshop on quantum chaos and information theory at IIT Chennai in 2010. Also delivered a special lecture on role of mathematics in physics in 2007. Also worked as coordinator of college women empowerment cell and UGC committee, and many such works are on her name. With immense request, we are too grateful to have you, ma'am, here. On behalf of management and students of our college, I once again welcome you, ma'am. So welcome you, ma'am. So over to you now.
Thank you very much, Pascal, for introducing me. And also, I would like to thank the principal and all the staff for giving me an opportunity to be here with all of you to share my experience as well as whatever the knowledge I have gained. And also, I would like to remember my PhD guide, Dr. Sudha, who brought me in touch with all of you to this webinar. With this, I would like to start whatever I wanted to convey to all of you. Am I sharing my screen, Pascal? Hello?
Ma'am, now you can share the share option is there now. You just press this. Now again you have to share.
Okay. Am I audible?
Yes, ma'am.
Okay. Yes, can you see my screen?
Yes, ma'am. Yes, ma'am. We are seeing.
Okay. We have got first year and second year PUC students, I guess, as
yes,
per
yes.
the information.
Yes, madam.
Okay. And also you had told me that I can use both Kannada as well as English.
Yes, madam. Yes.
And it would be more convenient if I use Kannada.
Yeah, yes, madam. So our students can understand both the language. So
good.
It is Kannada and both. If we are using, no, it will be better for us.
Okay, dear students, it will be. I'll be glad if you could communicate with us over the chat. And whatever the doubts you get, please put it on the chat box. Sir will convey to me. And also, I want you to be interactive. I'm going to ask a few questions in between my talk. If you could answer them, it will be very nice. In general, most of the topic you are already familiar with is where the mathematics really meets physics. There is an interesting reason behind choosing this topic. Whenever I took physics as my passion or whatever my subject, it was always a fascinating thing why there is too much of mathematics involved in this. There was always that question running in my mind. And also, when I became a lecturer, I noticed that most of the students, though they like mathematics, they don't want physics to means they don't want to continue in physics. They don't love physics, though there is too much of mathematics involved in it. So what really makes the students to hate physics or don't feel like continuing in the field of physics was the question that was disturbed running in my mind throughout for several years. But out of my teaching experience and also my personal experiences, I got to know that it is the missing part is we are not learning what is really the essence of physics or what is the language of physics. Then at that point, I too realized that it's the mathematics, the connection between physics and mathematics. Once we understand what is that relation, then definitely there are more chances of students liking physics. So I thought of sharing my ideas on this occasion. Let me start with this. Before that, I would like to ask few questions. You are already familiar with some of the concepts, at least not for the first year students. Some of the second year students might have noticed that you generally in physics textbook, if you open a physics textbook, there will be concepts like heat, light, sound, radiation, electricity, magnetism, kind of things. Do you agree with me? If yes, just write yes on the chat box. But the thing you might have surprised, why only these are the things taught to us in physics classes was the question. Means what is that connection really make us to learn these concepts? That I'm going to answer this in a couple of minutes. General definition which is taught to all of us is physics is a branch of science which deal with the study of nature. And remember, dear students, every branch of knowledge, like it may be literature, it may be history, it may be astrophysics, or it may be any Veda, or it may be any branch of physics, art, it may be science, and it may be dance, it may be music, whatever it may be. The aim of the subject is to understand the nature in a more and more better way and clear way. All the aim of all the subject is same, but the route we choose to understand the nature is different. That's all I can say about what is the meaning of saying understanding nature or the study of nature, when we define physics as a branch of physics which deals with the study of nature. It means what are the aspects that I can associate with the study of nature. Means I want to understand how the universe behaves, how does it behave, and what is the origin of universe, what are the constituent of universe, and constituent in the sense what forms the universe, like does it the matter alone, does it the energy alone, or is there any other parameters associated with it, kind of things we want to understand. This is the perspective of physics. Of course, the other branches of knowledge have got their own perspective of understanding physics, understanding nature, but the perspective of physics is we want to understand the universe in the form of matter, energy, space, and time. So these are the answers I have got when I say the study of nature. And in general, remember, we physicists, we use only 4 factors to understand the physics. That is only space, energy, mass, and time. Notice that you just consider anything in the universe, anything in the universe. It will be either it will be an empty space, or it will be some mass occupied in this, or it will be the form of energy, or it will be some time associated with the space. Of course, space and time, they are connected together. Or we physicists, we understand the universe only in terms of these 4 factors: space, mass, energy, and time. So I want you to focus on this so that you will be very clear about what really physics wants to do in spite of all those complicated mathematics involved in it. If you consider the space is the region of the space, it's very clear. And mass, you know how to define it. Energy, different forms of energy. Mass, when it comes to mass, we classify it's a matter, mass or matter, you can consider different state. There are different states of matter: solid state, liquid state, gaseous state, plasma state, kind of things we have classified. And also when it comes to energy, there are different forms of energy. That is why we in physics class we do teach light concept, heat concept, radiation concept, and all. And this is some questions I wanted to ask, but I don't think it is needed now. I have just defined what is matter. You know that it's a substance that has got inertia, and also which occupy anything which occupies space is can be considered as matter or some mass. And it exists in 4 forms. We already know that. And also it's composed of atoms, fundamental particles, and the measure of the matter is its mass. And also when it comes to energy, I just want to know that there are different forms of energy. Examples I have mentioned already. Light is a form of energy, sound is a form of energy, heat is a form of energy. Remember, why I want to emphasize it here means these are the concepts we generally teach in physics class. But why are we teaching that? Because we want to understand the universe in a better way. What are the because all these things, whatever, let us say light, let us say sound, let us say heat, or let us say solid state of matter, let us say liquid state of matter, whatever it may be, it falls into one of the categories of the 4 terms I mentioned. I want to understand what exactly these parameters means, these concepts are. For example, for instance, if I take light, have you seen the light ever? If I ask you, the answer I expect is we haven't. No, because light makes the things visible. The light itself is not at all visible to us, but we want to understand what is the structure of light and what constitute the light. That is why in physics class we teach corpuscular theory or corpuscular theory of light. And then comes the Huygens theory. Huygens, he made an attempt. He tried to understand the universe in a different way. Universe in the science sense, light he wanted to understand. So generally, that is why while teaching the concepts in classroom, we say, according to Huygens, this is the theory. According to Newton, this is the theory. Because we are not expressing our own theories. That's not our idea. In future, you may get some intuitive idea. You may prove it in a different way. That will become your own theory. But now, whatever we are teaching, they are the ideas of our ancestors, legends of physics. And that is why we express, according to Huygens, this is the understanding of light for us. And also in certain aspects, if that idea it fails at some stage, because that idea could not explain some of the other natural phenomena, like it could explain interference and diffraction very clearly, but it couldn't explain the polarization. Then another scientist, he proposed his own theory. He proposed his own theory, Maxwell's theory of light. Actually, it was electromagnetic. Light has got electromagnetic nature. The perspective or the understanding of light, it totally changes when Maxwell proposed his theory. Even Maxwell's theory should explain all the natural phenomena, then it will be a complete theory, so that we will be able to understand the light itself in a better way. Because we can't see light, we develop a model to understand light. We just develop a model to understand light. Similarly, even Maxwell's theory fails. It became an incomplete. Then Einstein introduced a photon concept. Light is not in the form of wave, it is like a packet in the form of packet of energy kind of thing. The idea is to understand a single concept, or whatever the phenomena we observe in nature, or whatever we have in nature, we need to develop models in physics. Whatever the concept introduced in syllabus is all those models which are already proposed by our scientists. That idea should always be there. We are learning whatever the things already invented. Why we need to learn the past? Because there are every chances that we may develop future, we may develop new future, a good future, or we ourselves bring up new concept, come up with new concept or new understanding of the same concept, we don't know. So we want our students to learn the past first in the same way they have proposed it, and then we expect them to develop new ideas or propose their own ideas, which makes the universe or the nature more and more clear for us. This is the idea. Yes, this is the same question I just wanted to ask. I just wanted to ask, have you ever seen all these concepts introduced in your syllabus? The answer must be yes, because as I mentioned in the beginning, we always teach only this type of concepts: heat, light, sound, radiation, electricity, magnetism, because all such things are found in nature. So we want to understand what is its form. For even in the when it comes to atomic models, we have not seen atoms. So the only option left for us is we need to develop a model. We haven't seen light, we need to develop a model to understand it. If your model, if it fits into the natural phenomena observed, then your uh, model is a wonderful model. We believe that the nature behaves in that according to that model. That is the idea. Please remember, most of the times at this point I wanted to emphasize, whatever you are learning in your textbook, it is completely a model based thing. It's a completely a model in the sense, all the concepts we really don't know how it looked like. We haven't seen electron, we haven't seen proton, we haven't seen atom, but we want to develop a model. We just make a guess, or we assume that it could be like that. So according to that, we prove it and we want to check it. Then only all such things are called models. Why the current electricity passes through a conductor, we don't know. So to understand that, we develop a model. And why some substances exhibit magnetic properties, actually it was unknown to us. Now we want to make it, means we want to understand it through some fundamental models. So the whole and sole idea of physics is to develop models to understand the nature through models. So whenever you come across a spherical distribution of charges and viscosity, where the liquid is treated as several layers of liquid models kind of thing. They're all models. And a straight conductor, solenoid is a model, circular distribution of charges, spherical distribution of charges. Everything is a model, remember. And these are some examples I just wanted to mention. When you are studying concept of free particle, free electron theory, and quantum free electron theory, particle in a box, that is also a model. Particle moving under a constant force, that is also a model. Simple harmonic oscillator, that is also a model. Simple pendulum is also a model. Compound pendulum is also a model. And Huygens theory, they have their own perspective. Dipole is also a model, and we believe that it exists. Also, it exists, and that is the interesting thing when it comes to reality. When you consider free particle in box, actually there are that's a concept we generally learn in physics, but there are a lot of applications of this concept to explain the electrical conductivity of metals and to explain the magnetic properties of metals, and to explain how the nucleons are distributed in the nucleus, and also in some branches of astrophysics, some concepts, we use the same single particle in a box model. So when you go to higher studies, definitely you are going to notice all these things. I just remember that all the concepts, they are models, and you are going to learn how to solve the model, how to develop that model, and how to solve it, and how to apply the laws of physics to the models is the idea. Most of the things, now I want to come to the main topic. I wanted all physics students to understand why physics is so important, and also what exactly we are learning when in physics classes was the idea. Because sometimes we feel very blind. Why are they teaching sound? We don't know. Why are they teaching light? We don't know. Why are they teaching us electricity? We don't know. But we learn it. Instead of that, if we could connect why are we learning all these things, it will be even more fascinating. That's what my idea. So I just thought of introducing some fundamental concept. Now I would like to come back to my main topic. Most of while learning all those things, so for example, a sound chapter, for example, light chapter, for anything, when you take any concept in physics, definitely always there will be some mathematics associated with it. So we find physics terrible or very difficult. Is it because of the too much of mathematics involved in physics? If when I ask this question to so many students of mine, the answer was absolutely yes. Actually, then following the same, you may think, is mathematics so much essential to learn physics? If this is a question, absolutely no doubt, physics is absolutely needed. It is an essential part of physics learning. Why? Because if you start with even the fundamental concepts in physics, like position, velocity, acceleration, momentum, force, torque, angular momentum, aerial velocity, anything you consider, anything you consider, we have in mathematical equivalent definition for all the fundamental concepts. When I know that velocity is just a fast moving particle, it's a vague way of understanding velocity. Every common man know that if an object is if something is moving very fast, wow, it was moving with a very high speed. That's what we speak generally. Our common sense knows that what is speed, but there it makes a difference to a common person, common man, and to a physicist. There is a difference. The difference is a common man can sense what is the speed of the object. He can sense the object is moving very fastly, but a physics student or a physics person, he knows that it is nothing but the rate of change of displacement. It's nothing but a rate of change of displacement, and when the direction is associated, I should call it as velocity. That's what makes the difference. And also a physics person, he can precisely tell what was exactly the speed, and what happens when it hits the other object, where we learn based on the collision chapter, based on the collision concept. Physics people can say its magnitude as well, its exact measured value also can be analyzed by a physicist. That is the difference. Of course, common sense, when it is a given a structure, when a specific structure or more scientific framework is given to common sense, definitely, especially this based on the laws of physics, then he becomes a physicist. Of course, common sense should work. Just for an instance, I want to know. Yes, the word position, it may sound like an English word to all of us. Actually, it just like a position means, oh, it's some position. We are used to use that word in a very casual way. Sit in the first position, sit in the second position, go to the last position, kind of thing. It's an English word, of course, but when physics, when it comes to physics, look at the thing. A physics person cannot use that word just like a simple position. He must be able to write the position vector for any particle moving, and we associate a position vector, and it may be a one-dimensional problem, it may be a two-dimensional problem, it may be a three-dimensional problem. Physics students must be able to write the position vector. Then whoever finds, means whoever can write the position vector, they know how to write the position vector very easily, then that student will find physics concept easier when compared to other person who vaguely tries to understand the concept of position. That vague understanding of position doesn't work unless and until we learn how to write the position in different coordinate system. It is very, very difficult to understand uh, the concepts, the other concepts in physics. See, look at the position is a very simple and the first concept we learn in physics. But notice that this doesn't exist. This concept cannot be used. We cannot use it unless we understand this position vector concept. And also, you know that this same concept, the coordinates concept, has been taught to you in your mathematics classes. Students, generally what we do is, we are good in mathematics, we know how to solve problems in Cartesian coordinates in mathematics, but the same thing when it comes to physics, and we use just instead of using vector A, we use it as a position vector A. We don't know how to connect that magnitude, definition, and cross product, dot product, and projection of the vector and all in physics. This is what exactly missing when I noticed many of my students. Just remember, both the concepts are same, but while studying the coordinate system in mathematics, it is a general vector. It is not necessarily a position vector always. It may be a vector A, vector B, vector C. But when it comes to physics, it could be a position vector, it could be a force, it could be velocity, it could be momentum. All vector quantities can be analyzed using the coordinate system. But we don't teach the Cartesian, how to work in Cartesian coordinate system in physics class. You need to refer to the mathematics class. So that is why it is very, very important to extend your mathematics knowledge while studying physics concept. It's very, very important. See, I just started with position. position was the first fundamental concept we introduced. Similarly, velocity. Velocity, you can notice that how do we define velocity? It is the rate of change of displacement. Notice that rate of change of displacement is not a English sentence. It is the language of mathematics where differentiation we use that sentence, we use that language. The variation of dx x with respect to is nothing but the rate of change of x with respect to time. Is the language of language is it's exactly, it is taken completely as it is from mathematics to physics. We have not at all altered the definition. Just look at you please notice that the rate of change of displacement, rate of change is nothing but, it's not just a normal English sentence. It is, there is a specific meaning for that in mathematics when we discuss the differentiation. So as it is, we have taken in physics. Even acceleration, when it comes to acceleration, it is the rate of change of velocity. It means you need to understand why the concept of differentiation is taught to us in mathematics class. Of course, for first year students, it's not had been not yet introduced probably. For the second year students, they are already familiar with the concept of differentiation and integration. Notice that the fundamental concept, velocity and acceleration, it has got a mathematics equivalent definition. It's not an English definition sentence we have got. It is the definition itself is mathematics. It means by defining the terminology or the quantity rather, it's a physical quantity, we have used mathematics. It's a mathematical definition. Why it is a mathematical definition? Because it should be, we want to quantify all these parameters. Unless I use mathematical concept, I won't be able to quantify it, how much it is. We don't know, because we know how to calculate it only in mathematics. So we have defined it. So at least now you must be careful. You must love integration and differentiation in mathematics class, and also you must be able to connect all those ideas, whatever you learn in mathematics class. While you you are in the physics class, you must be able to connect your ideas and whatever you have learned it. So don't think physics and mathematics are separate. They are actually they go hand in hand with each other. And also, I just wanted to mention what are the mathematical concepts we generally teach our students in their class. I have just mentioned 6 such concepts. You are learning more than that. Vector analysis. In mathematics class, we learn vector algebra, cross product, dot product of 2 vectors, and cross product of 2 vectors. Everything we learn, and how to add some subtract 2 vectors, kind of things. We learn some algebra. When you extend the same vector analysis to physics, you know that even in physics, the physical quantities themselves are vectors. The velocity is a vector, momentum is a vector, force is a vector, angular momentum is a vector, kind of things. And also when it comes to dot product of 2 vectors, you know that work done is nothing but, in mathematics we just learn that vector a dot b, but when it comes to physics, we will just ask you to find out what is the suppose the force is applied along some direction, and find out the particle gets displaced along z direction, what is the amount of work done on the object. If this is the question, the answer, the definition you need to use is force into displacement. Into means the dot product. Force is a vector quantity, displacement is a vector quantity. The kind of product that exists between the force and displacement is a dot product. And I know that the dot product of 2 vectors is going to be a scalar quantity, and that is as a vector work done. So remember, once you forget how to perform the dot product of 2 vectors in mathematics, and if you do not carry that, you won't be able to calculate how much work is done when the work done is given to you. Force and displacements are given to you. And also matrix algebra is also very important. Integration is very important, because integration, if you want to, in thermodynamics, if you want to find out what is the amount of work done, integration gives me the area under the curve. It is nothing but integration, the value of the integral. So if I know the function and find out the integral, and that is going to give me the area under the curve, gives me the work done. So there, based on the definition or in which context I'm dealing with, and when it comes to rectifiers, I want to find out the efficiency of the rectifiers, I must know integration. And there are so many concepts which are purely based on integration definitions. I cannot separate it from the context. And differentiation, I already mentioned, even the fundamental definition itself start from the velocity, acceleration, everything. It starts from the using the concept of differentiation. And note the definition itself says the sentence, it's from the mathematics, it's not at all from the English. But always while looking at the terminologies in physics, notice that most of the terminologies are mathematical terminologies, not English terms, not just English terms. For instance, if I say polarization, the word polarization, polarization is a general term. I use polarization in a general context also. Like all of us, all the students, they were polarized towards attending the program, is a kind of sentence I can frame using the word polarization. But when it comes to physics, it is I carefully use that word. Physics is polarization of light, polarization of electric polarization of light. They are two different concepts. Notice that what am I polarizing? When I say polarization of light, I'm going to analyze what I'm going to fix the orientation of the electric component of the light to a particular plane. This is how we understand. Though it sounds like a general term, everything has a different meaning in physics. Laplace transforms and Fourier transformations, when you go to higher level, you are going to learn all these things. But now probably you are familiar with the vector analysis, differentiation, integration, and curvilinear coordinates and all, etc. Thank you. And you know that some of the quantities we define it as physical quantities. This I wanted to mention because all the physical quantities, they have got both magnitude and direction. That is from the vector algebra. From the vector, just by looking at the way we express the physical quantities, that coefficient itself tells me the magnitude, so that you can analyze it very easily. And this is also whatever the laws we have used in vector algebra, they are purely defined in vector analysis, and it is directly taken while solving the physics problems. Just a few definitions I wanted you to recall. How do we define vector? And this vector in general, vector A, and we are in Cartesian coordinate system. There are so many different types of coordinate systems: spherical coordinate system, cylindrical coordinate, and all. This is just one Cartesian coordinate system. But when it comes to physics, it's not. AX means A has no meaning in physics. We need to define, is it a force, or is it a momentum, is it a velocity, is it a acceleration? The general vector, it takes a specific physical quantity. It becomes a specific physical quantity in physics. And this is another important thing I wanted to mention. This is you have already come across this equation of motion. Equation of motion means Newton's second law. You might have noticed F is equal to ma is the idea. Whenever, if you read textbooks, if you're second year students, if you open your textbooks, you will come across it is second order linear differential equation sentence called second order linear differential equations. You can notice that this m into a is mass into acceleration. Acceleration, I know it is d square y by dt square. It means second order derivative of displacement. If you look at any problems based on Newtonian mechanics, we first write the equation of motion, which is nothing but the force equation. F, first we write F, which is equal to ma, which is equal to the actual force acting on the particle. If we could correctly write what are the different types of forces acting on the object, then the 90% of the work is done. Because however, we are going to get a new second order linear differential equation. Why I mentioned, I wanted to mention here is, there is a concept called solving differential equations in mathematics. Differential equation itself is a very big chapter in mathematics. First order differential equation, second order differential equation, third order differential equations, and there are so many techniques to solve it. I wanted to you to notice that our Newton's second law itself is a second order linear differential equation. There is an equation called Schrodinger wave equation in quantum mechanics that is also a second order linear differential equation. When I saw upon solving Newton's second law, I'm going to get some means we get based on the problem, the solution will be different. Once I get solution X, I will be able to derive other parameters. If I know the position, I will be able to determine the velocity. So because after differentiating, and once I know the velocity, I can find out the acceleration. Once I know the velocity, I can find out means acceleration. I can also determine force. So the fundamental idea in Newtonian mechanics is to find out what is the position. How do I get position? After solving Newton's second law, which is a second order linear differential equation. Second year students, probably even first year students, you may ಈಗ start ಮಾಡ್ತೀರಾ ನೀವೆಲ್ಲರೂ, ಅದು ನೋಡಿದಾಗ you must be able to notice that this is a second order difference. ಅದನ್ನು ಸಾಲ್ವ್ ಮಾಡಿದ ನಂತರ ಬಂದಿರೋ ಉತ್ತರ ಅದು ಅನ್ನೋದು ಗೊತ್ತಾಗಬೇಕು ನಿಮ್ಗೆ. That is the idea. So that is a second order. It's not just start ಮಾಡ್ತಾನೆ ಇವ್ರು ಏನು ಈಕ್ವೇಶನ್ ಬರ್ದ್ಬಿಟ್ರಲ್ಲ and just you don't get surprised, because our fundamental law, Newton's law itself, is a second order differential equation. What mathematics teaches us is how to solve differential equations, which we don't do in physics. We want you to learn from mathematics classes. So learn the techniques from mathematics and apply the techniques in physics is what we expect. So just when you attend your next physics class, notice that if you are in a compo, if you are studying simple pendulum, if you are studying particle inclined on a means moving on in an inclined plane, and compound pendulum and torsional pendulum, whatever we write, and loaded spring theory, everything is purely based on Newton's laws of motion, and we use force equation. Force equation is a second order linear differential equation. We and also these oscillations, different types of oscillations, damped oscillations without damping, simple harmonic oscillation, everything is a what you write is a second force equation, second order linear differential equation. If you learn how to solve the linear differential equation, the things will be easier, and that's what we want you to learn. And after that, you know how to do algebra, but you must be able to notice that how the laws of physics are associated with the mathematical techniques. If you get stuck in techniques in physics, please refer to your mathematics textbooks and then continue. This is another thing I just wanted work done in terms of force and displacement. I just wanted you to notice. I already mentioned it, so I can skip this. So finally, what I want you to agree with, I wanted to ask you, can we consider mathematics as a language of physics? Because everything, including the fundamental definition, it starts with mathematical equivalence. As I said, uh, if you go to surface tension, even the definition of surface tension has got mathematical equivalence. When you teach viscosity, viscosity has got a model. Viscosity has got a model and definition for that. The standard definition generally, what is that? It measures the thickness of the liquid, or when it comes to surface tension, it is the surface of the liquid acts like a stretched membrane is the general definition we teach. But after that, we develop it's nothing but the force acting along the line, or the line curve is the kind of mathematical definition we finally arrive at, even in surface tension. So you consider any mathematical current. Current is also what is means we need to define how many charges are flowing per second. So I can think that every concept can be expressed in mathematics language. I can treat mathematics as a language of physics, and also in a broader sense, we also know that mathematics is a general tool, or it's a general language to express most of the concept. If any one of you are a dancer, you will definitely tell that the dance is purely mathematical in nature. If some of you must be a musician, or it may be you may be a singer, you will definitely say mathematics. Without mathematics, I cannot play music. That's also absolutely right. It's a universal language, mathematics. So even for physics, physics cannot be expressed unlike the other subjects without mathematics. This is what I wanted to convey to all of you. If there are any queries, I think I can take.
So, okay, thank you, ma'am. That is a wonderful session. So now I think the students have understood why we are going to use mathematics in all the topics of physics. So here we have some questions.
Yes,
Dear students,
please.
if you have any other questions, you can put it in chat box. So now we have some questions. Now, ma'am will ask the question.
Okay, first question is like this, ma'am.
Sure. Yes, ma'am.
Any object will become invisible.
Okay.
It moves with very high speed.
No.
Why? Any object will become invisible if it moves with very high speed.
If the particle moves with very high speed, it becomes invisible.
Why?
Why?
These are general questions that one of our students, Dilawar, asked this. So you are saying that if an object is moving with a very high speed, it will be invisible. So what is the reason like this he is asking?
So there is an ambiguity. Who said it will become an invisible kind of things? I don't know. Yeah. But it follows time dilation. That kind of things are there actually. Invisible from the what is that? View of from the view, it may become invisible. That's fine. Yeah. I don't know. Maybe some incompleteness is there.
I think if
I did not understand question clearly. I did not understand it clearly. But what when I say when the object is moving to when it is moving with very fast speed, or even the velocity equal to the velocity of light, it just brain get connected to a theory of relativity. Yes. And I can just understand that it experiences time dilation, it experiences mass kind of thing. That's it, means weightlessness kind of thing. But this it's not getting connected to any of this. So maybe they have got some other idea, probably not.
Maybe I think in general he has taken. I think if you are watching,
maybe.
it is moving with very high speed. It looks like it is invisible. Maybe that kind of thing he was asking, but generally it is not invisible only.
Maybe that is length contraction is there actually. Whenever even in the theory of relativity, that concept is there. When the object moves with a very high velocity, there will be length contraction. The result is length contraction. Length contraction means it looks less smaller than what it is actually for us.
Yeah.
That maybe that is what she wanted to, or he or she maybe wanted to express actually. Yes, it is mentioned. It's one of the consequences of the general theory of relativity. It's as a result of your derivation ಅದು ಬಂದೇ ಬಿಡುತ್ತೆ ನಿಮ್ಗೆ.
ಹೌದು ಅಂದ್ರೆ ಯೂಶುವಲಿ ಅದು ಅಂದ್ರೆ ಅವರು ಕ್ವೆಶ್ಚನ್ ಕರೆಕ್ಟ್
ಕರೆಕ್ಟ್. ಓಕೆ ಅಂದ್ರೆ ಮೇ ಬಿ ಇದೇ ಅವ್ರಿಗೆ ಕನೆಕ್ಟ್ ಆಗ್ತಾ ಇದ್ರೆ ಹೌದು. ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ ವೆನೆವರ್ ದ ಪಾರ್ಟಿಕಲ್ ಮೂವ್ಸ್ ವಿತ್ ವೆರಿ ಹೈ ಸ್ಪೀಡ್ ಲೆಂತ್ ಕಾಂಟ್ರಾಕ್ಷನ್ ಆಗೋಗ್ಬಿಡುತ್ತೆ. ಅದನ್ನ ಅಬ್ಸರ್ವ್ ಕೂಡ ಮಾಡಿದ್ದಾರೆ. ಅದು ನೀವು ಹೇಳ್ದಾಗೆ ಅದು ಕಾಣಿಸೋದಿಲ್ಲ ಆಬ್ಜೆಕ್ಟ್ ಅಂತ ಬಿಟ್ಟು. ದಟ್ ಇಸ್ ಬಿಕಾಸ್ ಆಫ್ ದ ಲೆಂತ್ ಕಾಂಟ್ರಾಕ್ಷನ್.
ಅದೇ ಅದು ಲೆಂತ್ ಕಾಂಟ್ರಾಕ್ಷನ್ ಆಗ್ತಿರುತ್ತೆ ಅವರಿಗೆ.
ಎಕ್ಸಾಕ್ಟ್ಲಿ ಎಸ್, ಅವರಿಗೆ ಹೇಳ್ಬೇಕು. ಅವ್ರ ಹೆಸರು ನಂಗೆ ಗೊತ್ತಿಲ್ಲ, ಯಾರು ಬರ್ದಿರೋದು. Ilavar, there is a theory called general theory of relativity in physics. Adradu direct consequence idappa. Any object, any lengther object or any size object, when it is moving with the velocity equal to that of light or very fast, move aagta ide andid koodle, it doesn't apparently, it looks lesser in size. Hagagi namge ಕಾಣಿಸ್ತಿಲ್ಲ ಅಂತ ಅನ್ಸುತ್ತೆ. ಹಾಗಾಗಿ ಇದೆ ಥಿಯರಿ ಇದೆ ಅದಕ್ಕೆ.
Okay, I will explain. Okay. So we have one more question.
What is mathematical tool for physics?
So there is one question regarding what is mathematical tool for physics, or some same girl only mentioned that what is the difference between this mathematics and physics, what we are studying. So
mathematics itself is a tool for physics actually. ಅದೇ ಹೇಳ್ತಾ ಇರೋದು. ಪೊಸಿಷನ್ ಅಂತ ಹೇಳಿದ ಕೂಡ್ಲೇನೆ ನಮ್ಗೆ ಪೊಸಿಷನ್ ವೆಕ್ಟರ್ ಬರೆಯಕ್ ಬಂದ್ಬಿಡ್ಬೇಕು ಅಂತ. ದಟ್ಸ್ ವಾಟ್ ವಿ ಎಕ್ಸ್ಪೆಕ್ಟ್. ಆ ಪೊಸಿಷನ್ ಅಂತ ಹೇಳ್ತಿದ್ದಾಗ ಬ್ರೈನ್ ಅಲ್ಲಿ ಕನೆಕ್ಟ್ ಆಗೇ ಬಿಡುತ್ತೆ. ವೆಲಾಸಿಟಿ ಅಂತ ಹೇಳ್ತಿದ್ದಾಗೇನೆ ಅದು ನಮ್ಮ ಸೆನ್ಸ್ ಏನ್ ಹೇಳ್ತಿರುತ್ತೆ, ಫಾಸ್ಟ್ ಆಗಿ ಮೂವ್ ಆಗ್ತಾ ಇರೋ ಪಾರ್ಟಿಕಲ್ ಅಂತ ಹೇಳಿದ್ರು ಕೂಡ ಫಿಸಿಕ್ಸ್ ನವ್ರಿಗೆ ಏನಾಗ್ಬಿಡ್ಬೇಕು ಅಂತ ಹೇಳಿದ್ರೆ dr/dt ಬರೆಯಕ್ ಪೊಸಿಷನ್ ವೆಕ್ಟರ್ ನ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡಕ್ ಬಂದ್ಬಿಡ್ಬೇಕು ಅಂತ ನಾವ್ ಎಕ್ಸ್ಪೆಕ್ಟ್ ಮಾಡೋದು. ಎರಡು ದೇ ಗೋ ಹ್ಯಾಂಡ್ ಇನ್ ಹ್ಯಾಂಡ್. ಆ ಕಾಮನ್ ಸೆನ್ಸ್ ಒಂದ್ ಕಡೆ ಕೆಲಸ ಮಾಡ್ತಾ ಇರುತ್ತೆ, ಈ ಕಡೆ ಅದಕ್ಕೆ ಈಕ್ವೇಶನ್ ಬರೆಯೋಕು ಬಂದ್ಬಿಡ್ಬೇಕು. ಚಿತ್ರ ನೋಡಿದ ಕೂಡಲೇ ಈಗ ಹೇಳ್ತಾರೆ, ಒಂದ್ ಪ್ರಾಬ್ಲಮ್ ಸಾಲ್ವ್ ಮಾಡ್ತಾ ಇರ್ತಾರೆ ಕೆಲವು ಸತಿ ಮಕ್ಕಳು. ಒಬ್ಬರು ಆರಿಜಿನ್ ಇಂದ ಫಸ್ಟ್ ಗೆ ಈಸ್ಟ್ ಗೆ ಹೋಗ್ತಾರೆ 3 ಕಿಲೋಮೀಟರ್, ಆಮೇಲೆ 2 ಕಿಲೋಮೀಟರ್ ವೆಸ್ಟ್ ಗೆ ಹೋಗ್ತಾರೆ, ಆಮೇಲೆ ಮತ್ತೆ ಅಲ್ಲಿಂದ 2 ಕಿಲೋಮೀಟರ್ ನಾರ್ತ್ ಗೆ ಬಂದ್ರು ಅಂತ ಹೇಳಿದ ಕೂಡಲೇ ಗ್ರಾಫ್ ಪ್ಲಾಟೇ ಮಾಡ್ಬಿಡ್ತಾರೆ ಮಕ್ಕಳು. ಏನಂತ XYZ ಹಾಕಿದ್ರು, ಇದು ಎಕ್ಸ್ ಮತ್ತೆ ವೈ ಆಕ್ಸಿಸ್ ಹಾಕಿ ಡ್ರಾ ಮಾಡ್ತಾರೆ. ಈಸ್ಟ್ ವೆಸ್ಟ್ ವೆಸ್ಟ್ ಅಂತ ಚಿತ್ರ ಹಾಕಿ ಫೈಂಡ್ ಔಟ್ ದ ಫೈನಲ್ ಪೊಸಿಷನ್ ಅಂದಿದ್ ಕೂಡಲೇ ವೆಕ್ಟರ್ ಡ್ರಾ ಮಾಡೇ ಬಿಡ್ತಾರೆ ಜಿಯೋಮೆಟ್ರಿನ. ದಟ್ಸ್ ವಾಟ್ ವಿ ಎಕ್ಸ್ಪೆಕ್ಟ್ ದೆಮ್ ಟು ಡೂ ಇನ್ ಫಿಸಿಕ್ಸ್. ಸೊ ಆ ಸ್ಕಿಲ್, ಹಾಗಾಗಿ ಮ್ಯಾಥಮೆಟಿಕ್ಸೇ ಟೂಲು ನಮ್ಗೆ ಫಿಸಿಕ್ಸಿಗೆ ಅಂತ. ಆ ಟೂಲ್ ಇಲ್ದೆ ಅಂದ್ರೆ ಅಲ್ಲಿ ಏನ್ ಕಲಿತಿರೋ ಅದನ್ನ ಇಲ್ಲಿ ಬಿಟ್ಟು ಬರ್ಬೇಡಿ ಅಂತ, ಫಿಸಿಕ್ಸಿನಾಗೆ ತಗೊಂಡ್ ಬನ್ನಿ. ಇದ್ ಯಾಕೆ ಹೀಗ್ ಮಾಡ್ತಾ ಇದೀವಿ ಅನ್ನೋದನ್ನ ಬಿಡಬೇಡಿ ಅಂತ.
Okay ma'am, I have one question.
ಕೇಳಿ.
As I am teaching in this PUC, so PUC ನಾವು ಪಾಠ ಮಾಡ್ಬೇಕಾದ್ರೆ, so the students just they have finished SLC and they will come to this PUC.
Correct.
In first year physics, there are so many topics related to this energy is there, laws of motion is there. So these are all okay. One question is that we are using, you have mentioned that we are using matrices and the differentiation and integration. These things we are using in first years. So but this main I am feeling like it is a little difficult because they are studying that in very deep in second year mathematics.
Correct.
This
that was the mistake I did in the revised syllabus. I don't know why they did so actually, but when it was in the when we were studying, actually it was good enough. Some of the concepts they have reframe ಮಾಡ್ಬಿಟ್ಟಿದ್ದಾರೆ. ಅಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ತಗೊಂಡ್ಬಂದ್ಬಿಟ್ಟು ಇಲ್ಲಿ ಕಾನ್ಸೆಪ್ಟ್ ಸ್ಟಾರ್ಟ್ ಆಗ್ಬಿಡುತ್ತೆ ಫಿಸಿಕ್ಸ್ ಅಲ್ಲಿ, ಅಲ್ಲಿ ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ಇಂಟ್ರೊಡ್ಯೂಸ್ ಆಗಿರೋದಿಲ್ಲ. ಸೊ ವೆರಿ ಡಿಫಿಕಲ್ಟ್ ಪಾಠ. ಆಕ್ಚುಲಿ ಫಿಸಿಕ್ಸ್ ನವ್ರಿಗೆ ಕಷ್ಟ ಆಗುತ್ತೆ ಪಾಠ ಮಾಡಕ್ಕೆ, ಯಾಕೆಂದ್ರೆ ನೀವು ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ಟೀಚ್ ಮಾಡ್ಕೊಂಡು ಪಾಠ ಮಾಡ್ಬೇಕಲ್ವಾ, ಅಲ್ಲಿ ಕಷ್ಟ ಆಗ್ಬಿಡತ್ತೆ ಅಂತ ನಂಗೆ ಅನ್ಸೋದು ಅಲ್ವಾ. ಈಗ ಡಿಫ್ರೆನ್ಸಿಯೇಷನ್ ಅಲ್ಲಿ ಮ್ಯಾಥ್ಸ್ ಅಲ್ಲಿ ತುಂಬಾ ಫಂಡಮೆಂಟಲ್ ಇಂದ ತುಂಬಾ ಪ್ರಾಬ್ಲಮ್ ಸಾಲ್ವ್ ಮಾಡ್ತಾರೆ. ನೀವು ಅಷ್ಟನ್ನ ಇಲ್ಲಿ ಹೇಳ್ಕೊಡಕ್ ಆಗುತ್ತಾ? ತುಂಬಾ ವೆರಿ ಡಿಫಿಕಲ್ಟ್. ಅದಕ್ಕೆ ಅಲ್ಲಿ ಇಂಟ್ರೊಡ್ಯೂಸ್ ಆಗ್ಬಿಡ್ಬೇಕು ಅಂತ ನಾನು ಹೇಳೋದು. ನಂಗೆ ಅನ್ಸಿದ್ದು
ಈಗ ಫಸ್ಟ್ ಇಯರ್ ಗೆ ಅವ್ರು ಜಸ್ಟ್ ಬಂದಿರ್ತಾರೆ, ನಾವು ಮ್ಯಾಟ್ರಿಸಸ್ ಇಂಟಿಗ್ರೇಷನ್ ಡಿಫ್ರೆನ್ಸಿಯೇಷನ್ ಹೇಳಿದ ತಕ್ಷಣ ಅವ್ರಿಗೆ ಮತ್ತೆ ಫಿಸಿಕ್ಸ್ ಅಲ್ಲಿ ಇನ್ನು ಸ್ವಲ್ಪ ಅವ್ರಿಗೆ ಫೀಲಿಂಗ್ ಬಂದ್ಬಿಡುತ್ತೆ.
ಇಲ್ಲಪ್ಪ, ಕರೆಕ್ಟ್. ನಿಮ್ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಕರೆಕ್ಟ್ ಅದ. ಆಕ್ಚುಲಿ ಫಿಸಿಕ್ಸ್ ನವ್ರಿಗೆ ತುಂಬಾ ಕಷ್ಟ ಆಗ್ಬಿಡುತ್ತೆ, ಸಾಧ್ಯನೇ ಇಲ್ಲ. ಯಾಕೆ ಅಂತ ಹೇಳಿದ್ರೆ, ಒಂದು ಸ್ಟೂಡೆಂಟ್ ಈಗ 10ನೇ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಯಾವ ರೀತಿ ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ಕಲ್ತಿರ್ತಾರೆ ಅಂತ ನಮಗ್ ಗೊತ್ತು. ದಟ್ ಇಸ್ ಸಿಂಪಲ್ ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ವೆನ್ ಕಂಪೇರ್ ಟು ಫಿಸಿಕ್ಸ್, ಇದು ಹೈಯರ್ ಲೆವೆಲ್ ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ಗೆ PUC ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ. ಆದ್ರೆ ಅವರು ಆ ಗ್ಯಾಪ್ ಅಲ್ಲಿ ನಮ್ಗೆ ಅಷ್ಟು ಇಲ್ಲ ಅಂತ ಹೇಳೋದ್ರಿಂದ ನಮ್ಗೆ ಫಿಸಿಕ್ಸ್ ಕಾನ್ಸೆಪ್ಟ್ ಅಲ್ಲಿ ತಗೊಳಕ್ ಆಗೋದೇ ಇಲ್ಲ. ಯಾಕಂದ್ರೆ ಫಿಸಿಕ್ಸ್ ಅಲ್ಲಿ ಮ್ಯಾಥ್ಸ್ ಅಲ್ಲಿ ಕಲ್ತಿದ್ರೆ ಮಾತ್ರ ನಮ್ಗೆ ಇಲ್ಲಿ ನೆನಪಿಸೋದು ನಾವ್ ಅಷ್ಟೇನೆ. ಇಲ್ಲಿ ಈಗ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಅದೇ ನೀವ್ ಹೇಳ್ದ ಹಾಗೆ ಈ ಡಿಫ್ರೆನ್ಸಿಯೇಷನ್ ಬಂದಿದ್ರೆ ನಮ್ಗೆ ಒಂದ್ ಸ್ಟೆಪ್ ಈಸಿ, ನೋಡಿ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡ್ತಾ ಇದೀನಿ ಅಂತ ಹೇಳ್ಬಿಟ್ರೆ ಮಕ್ಳು ಬ್ರೈನ್ ಕನೆಕ್ಟ್ ಮಾಡ್ಕೋತಾರೆ, ಹೌದು ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡ್ತಾ ಇದೀವಿ ಅಂತ ಅಂದ್ಬಿಟ್ಟು. ಇಲ್ಲಿ ಡಿಫ್ರೆನ್ಸಿಯೇಷನ್ ಟೀಚ್ ಮಾಡಿ ಅಂದ್ರೆ ದಟ್ಸ್ ಟೋಟಲಿ ಡಿಫ್ರೆಂಟ್ ಸ್ಟ್ರೀಮ್. ನಿಮಗ್ ಕಷ್ಟ ಆಗುತ್ತೆ, ಅಂದ್ರೆ ನಮ್ಗೆ ಒಟ್ಟು ಪಾಠ ಮಾಡುವಾಗ ಕಷ್ಟ ಆಗತ್ತೆ. ಅದಕ್ಕೆ ಒಂದೇ ಸೊಲ್ಯೂಷನ್ ಏನು ಅಂತ ಹೇಳಿದ್ರೆ, ಅದಕ್ಕೆ ಒಂದು ಸ್ವಲ್ಪ ಇದು ಏನಪ್ಪಾ ಅಂದ್ರೆ ಒಂದು ಟೈಮ್ ಕೊತ್ಕೊಂಡು ಮಕ್ಳು ಬರ್ದು ಕಲಿಯೋದು ಅಂತೂ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡ್ಲೇಬೇಕು ಸ್ವಲ್ಪ ದಿನ. ಆಮೇಲೆ ಅವ್ರಿಗೆ ಒಂದ್ಸತಿ ಇಲ್ಲೂ PUC ನಲ್ಲಿ ಓದೋದು ಹೆಂಗೆ ಅಂತ ಒಂಚೂರು ಅಭ್ಯಾಸ ಆಗಿದ್ ಕೂಡ್ಲೆ ಆಮೇಲೆ ಈಸಿಯಾಗಿ ಓದ್ತಾರೆ. ಯಾಕಂದ್ರೆ PUC ನಲ್ಲಿ ಸಿಲೆಬಸ್ ಆಗಿರ್ಬಹುದು, ಕಂಟೆಂಟ್ ಆಗಿರ್ಬಹುದು, ಮತ್ತೆ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಗಳ ನಂಬರ್ ಆಗಿರ್ಬಹುದು, ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ನ ಸೈಜ್ ಆಗಿರ್ಬಹುದು, ಎಲ್ಲವೂ ಕೂಡ SSLC ನಲ್ಲಿ ಕಡಿಮೆ ಇರುತ್ತೆ. PUC ಬಂದಿದ್ ಕೂಡ್ಲೆ ಆಲ್ ಆಫ್ ಎ ಸಡನ್ ನೋಡಿ ಫಿಸಿಕ್ಸ್ ಅನ್ನುವಂಥದ್ದು ಏನೋ ಒಂದ್ ಪಾರ್ಟ್ ಓದಿರ್ತಾರೆ, ಇಲ್ಲಿ 2 ಪುಸ್ತಕ ಬಂದ್ಬಿಡತ್ತೆ ಒಂದೇ ಸತಿಗೆ. ಮ್ಯಾಥ್ಸ್ ಒಂದ್ ಪಾರ್ಟ್ 2 ಪುಸ್ತಕ ಓದಿರ್ತಾರೆ, ಅದು ಸ್ವಲ್ಪ ಚಿಕ್ಕ ಅದ್ರಲ್ಲಿ ಪರವಾಗಿಲ್ಲ. ಇಲ್ಲೂ 2 ಪುಸ್ತಕ ದೊಡ್ಡ ಬಂದ್ಬಿಡುತ್ತೆ. ಅದಕ್ಕೆ ಟ್ಯೂನ್ ಆಗಲ್ಲ ಅಂತಲ್ಲ, ಎಲ್ರು ಆಗ್ತಾರೆ. ಆಕ್ಚುಲಿ ಎಲ್ಲಾ ಮಕ್ಳಿಗೂ ಆ ಕೇಪಬಿಲಿಟಿ ಇರುತ್ತೆ. ಟೈಮ್ ಬೇಕು. ಆ ಟೈಮ್ ಅಲ್ಲಿ ಅವ್ರನ್ನ ಬರ್ಸಿ ವರ್ಕ್ ಮಾಡಿಸಿದ್ರೆ 4ನೇ ತಿಂಗಳಿಗೆ ಪಿಕಪ್ ಆಗ್ಬಿಡ್ತಾರೆ.
ಥ್ಯಾಂಕ್ ಯು ಮ್ಯಾಮ್. ಮತ್ತೆ ಯಾರು ಏನಾದ್ರು ಕ್ವಶನ್ ಇದ್ರೆ ಕೇಳ್ಬೋದು ಮ್ಯಾಮ್. ಫೈನಲಿ ಸೊ ಲಾಸ್ಟ್ ವಿ ಹ್ಯಾವ್ 3 minutes to go. ನಿಮ್ಗೆ ಏನಾದ್ರು if you want to give any study tips for students, so how to cope up with both ಅಂತ ಹೇಳ್ತೀನಿ.
ಖಂಡಿತ. ನಾನು ಐ ವುಡ್ ಸಜೆಸ್ಟ್ ದ ಸ್ಟೂಡೆಂಟ್ಸ್ ಟು ಮೇಕ್ ಯೂಸ್ ಆಫ್ ಟೀಚರ್ಸ್ ಮೋರ್ ಎಫೆಕ್ಟಿವ್ಲಿ. ಫಸ್ಟ್ ಆಫ್ ಆಲ್ ನಿಮ್ ತರ ಎಲ್ಲ ಇಂಟ್ರೆಸ್ಟೆಡ್ ಟೀಚರ್ಸ್ ಇರೋವಾಗ ನನ್ನ ಕೇಳಿದ್ರೆ ಎಲ್ಲಿ ಮಿಸ್ ಮಾಡ್ತಿದ್ದಾರೆ ಈಗಿನ ಮಕ್ಳು ಅಂತ ಕೇಳಿದ್ರೆ, ಟೀಚರ್ಸ್ ನ ಹಿಡ್ಕೋಬೇಕು. ನಮ್ಗೆ ಇದನ್ನ ಹೇಳ್ಕೊಡಿ, ನೀವು ನಮ್ ಜೊತೆ ಇರಿ, ನಮ್ ಜೊತೆ ಕುತ್ಕೊಡಿ, ನಾವು ಕುತ್ಕೋತೀವಿ ಇವಾಗ ವರ್ಕ್ ಅಂತ ಅವ್ರು ಹಿಡ್ಕೊಳ್ಳಿಲ್ಲ ಅಂತ ಹೇಳಿದ್ರೆ ದೇ ಲೂಸ್ ಟೂ ಮಚ್ ಆಫ್ ಥಿಂಗ್ಸ್. ಅದ್ರಲ್ಲಿ ನಂಗೆ ಯಾವ ಡೌಟು ಇಲ್ಲ. ಈಗಿಂದು ನಾನ್ ತುಂಬಾ ಟ್ರೆಂಡ್ ಗಮನಿಸ್ತಿರೋದು ಏನು ಅಂತ ಹೇಳಿದ್ರೆ, ಈ ಬಿಟ್ರೆ ಸಾಕು ಕ್ಲಾಸ್ ಇವ್ರು ಅಂತ ಅವ್ರದೇ ಎಲ್ಲೋ ಒಂದ್ ಮೊಬೈಲ್ ಲೋಕ, ಅವ್ರದೇ ಎಲ್ಲೋ ಒಂದ್ ಮಾತಾಡೋ ಲೋಕ, ಅವ್ರದೇ ಯಾವ್ದೋ ಒಂದ್ ಫ್ರೆಂಡ್ಸ್ ಲೋಕ, ಅಲ್ಲಿ ಕಳ್ದು ಹೋಗ್ತಾ ಇದ್ದಾರೆ. ಹಂಗ್ ಮಾಡ್ಬೇಡಿ ಅಂತ ದಟ್ಸ್ ಮೈ ರಿಕ್ವೆಸ್ಟ್ ವಿತ್ ಆಲ್ ದ ಸ್ಟೂಡೆಂಟ್ಸ್. ಮೇಕ್ ಯೂಸ್ ಆಫ್ ಯುವರ್ ಟೀಚರ್ಸ್ ವೆರಿ ಎಫೆಕ್ಟಿವ್ಲಿ. ಯುವರ್ ಫ್ಯೂಚರ್ ವಿಲ್ ಬಿ ವೆರಿ 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 ಬ್ರೈಟ್ ಅಂತ. ದಟ್ಸ್ ವಾಟ್ ಐ ಕ್ಯಾನ್ ಕನ್ವೆ. ಯಾಕೆಂದ್ರೆ ನಿಮ್ ಜೊತೆ ಕೂರ್ಸ್ಕೊಳ್ಳಿ ನಿಮ್ ಟೀಚರ್ಸ್ ನ, ನೀವು ಕುತ್ಕೊಂಡು ವರ್ಕ್ ಮಾಡಿ. ನಾವ್ ಇವಾಗ ಮಾಡ್ತೀವಿ ಸರ್, ಇವತ್ತು ನಾನು ಏನ್ ಕಲ್ತ್ಕೊಂಡ್ ಬರ್ಲಿ, ಕೇಳ್ಕೊಂಡ್ ಹೋಗಿ, ನಾಳೆ ಕಲ್ತ್ಕೊಂಡ್ ಬನ್ನಿ, ಅದನ್ನ ತೋರ್ಸಿ ನೀವೇನೆ. ಟೇಕ್ ಪರ್ಸನಲ್ ಇಂಟ್ರೆಸ್ಟ್. ನೀವು ಬೆಳಿಬೇಕು ಅಂದ್ರೆ ನೀವೇ ಇಂಟ್ರೆಸ್ಟ್ ತಗೋಬೇಕು. ಅಂಡ್ ರಿಸೋರ್ಸ್ ಇದೆ, ರಿಸೋರ್ಸ್ ಇದ್ದಾಗ್ಲೂ ನೀವು ಉಪಯೋಗಿಸ್ಕೊಳ್ಳಿಲ್ಲ ಅಂತ ಹೇಳಿದ್ರೆ ಯು ವಿಲ್ ಬಿ ದ ಲೂಸರ್ಸ್ ಅನ್ನೋದು ನನ್ನ ಅಭಿಪ್ರಾಯ. ಸೊ ಐ ರಿಕ್ವೆಸ್ಟ್ ದೆಮ್ ಟು ಮೇಕ್ ಯೂಸ್ ಆಫ್ resource persons like you all ಅಂತ.
Okay, thank you ma'am. I think our students has listened to your words, so I think from tomorrow onwards they can ask us questions.
Sure, I will be very glad if they ask. Please let me know.
We are also like that as that kind of students only. They will give us a little work to do also, no? So that will be fine, I think. Okay ma'am, we will end this session now. So
okay, thank you very much for the opportunity. Please convey my regards.
Conclude with this vote of thanks.
Okay.
Dear Lord, thank you for this gift of education and knowledge. As we had gathered here on this wonderful webinar, I extend my gratitude and heartfelt thanks to the keynote speaker of webinar, Dr. Divyamani BG. So thank you, ma'am.
Thank you very much.
So I extend my thanks to the college and the management. My sincere thanks to the principal, Mr. Sunny Godino. Thank you, sir. So I thank the vice principals, Vice Principal Pushpalataras and the Principito. So, and the coordinator of this webinar, Mrs. Kavita. So, thank you, ma'am. So, last, I thank all the participants who are participating in this webinar and make it as a successful. So, I request the participants. So, I have sent you the link there, so you can give their feedback. And after giving the feedback, you will get your certificate. So, it will be a certificate provided for you, the participation certificate. So thank you, ma'am. Thank you, everyone.
Thank you very much, Pascal.